Okay, so we have been talking about modeling populations and what kinds of things impact populations. Now, I'm hoping you already checked out our video clip of the Ngorongoro crater. And it's such a beautiful place. And it's an opportunity for you to examine some different populations of organisms that you might not normally see, lions, zebras. And we talk about populations as a group of organisms that are all in the same species that all happen to live in a certain area, such as the Ngorongoro crater. Now, we also started looking at what impacted a lion population in the crater in 1962. In 1962, there were these crazy rains, and it brought in these blood-sucking stable flies, and these flies drained all the blood and made skin sores and made the lions really sick. And then we asked you to check out what happened and use some computer models and use some math to model specifically what happened to the African populations on the Concordia simulation. Now, if you haven't already done that, I'd like you to do that at this time. And if you haven't already taken your checkpoint on Schoology, I want you to try that at this time too. Now, once you've done those things, I'd like you to think about what you saw in your math models. So first of all, remembering that mathematical representations of populations are the way we support our explanations of what's going on. And really, scale continues to be really important here, just like it did when we were talking about how temperature changes in different situations and carbon dioxide levels. We have to look at scale. So when we compare the type of changes that we see here to the type of the changes we see here, those are a different scale. We will call this a small scale change and this a large scale change. And we can see that this is a significant difference because we are seeing a very large change between what was going on before. Now, what might cause these minor fluctuations? Pause me while you think about that for a second. Now, you might have thought, well, regular populations have normal increases and decreases due to seasonal changes, due to babies being born and lions dying and all kinds of organisms. They have regular little ups and downs throughout the year. However, or even throughout a couple years. However, what about this major change? What caused this major change right after 1962? Pause me while you think about that. Hopefully you said something about, well, there was a lot of rain, and with an increase in rain, there was an increase of flies, which meant there was an increase of sick lions who died. We see this big drop in the population. Now, what we do with our models, whether they're simulations or mathematical, is we use them to make a prediction. And so as I look at what's happening here in 1962, by 1963, we have a very small lion population here. I want you to make a prediction. How will the population, this very small population of lions, grow when they really don't have anybody to share this Ngorongoro crater with? They're down there, it's just a few lions, just over 10. How is that population going to grow? All right, now that you've made your prediction, let's think about one possibility. You might have said exponential growth. You might have said, well, with lots of food around, the population is going to go super duper fast. They're going to have lots of babies and they won't have to compete, so they're all going to live and all get enough. So if we would see exponential growth, we would expect to see this sharp upward curve. Now, let's test this prediction and take a look. Did our population of lions actually show exponential growth? Maybe a little bit in the beginning. Does it continue to grow exponentially? Well, let's see and take a look at what happens after 1981. Because after that point, you have to pay attention to the fact that the population has gotten big enough where now there are limiting factors. And we would expect populations to continue with exponential growth if it were not for limiting factors. And these limiting factors would be things like living and non-living resources and challenges like predation, competition, and disease. Pause me for a minute while you think about the kinds of limiting factors that impact our lions. Now, you might have said limiting factors could be things like zebras that they eat, or the impala that they eat, or availability of water is a really good one in Africa. You might again have brought up the diseases that popped up, and maybe who would prey on lions? Maybe hunters, human hunters. So those are possible limiting factors. Now, when we take a look at the carrying capacity, we're trying to figure out exactly how much these limiting factors impact a population. These limiting factors are going to kind of keep a population in check. And when that happens, we see this distinctive shape where the population initially shows exponential growth and then starts to level off as all that competition for limiting factors keeps it in check. And we measure carrying capacity by drawing a line, and normally you'll see ups and downs, the small scale changes, but you draw a line kind of right through the middle of those, and you trace it over, and you say to yourself, okay, the carrying capacity of this particular bacterial population in this example is going to be around 6,000. Well, when we see this distinctive S-shaped curve, we actually call that logistic growth. And that's when our limiting factors affect our population, and it actually has this S-shaped curve. So what is the carrying capacity before the stable fly infestation? And what do you think will happen 20 to 25 years after that stable fly infestation? So think about that for a minute and pause me. Okay. Hopefully you noticed this line I helped put in here for you and saying like, all right, the compared carrying capacity before that stable fly infestation was about 80 lions. And let's see what happens later. From 1990 to 2012, we go here, here was the early, then we had the drop in the 60s, then we had this sharp growth, and there are ups and downs and ups and downs and ups and downs. Oh, 1990 to 2012, what happened there? Let's compare the carrying capacities in the 60s to 1990 to 2012. How do they compare? Do you notice that this carrying capacity is significantly lower? So before the big infestation of flies, we were around 80 lions in the crater with increases and decreases. But from 1990 to 2012, we're seeing a much lower number, more close to 55 lions. Why do you think that's true? And this helps us pivot to our next activity, where we talk about maybe how humans